Now it says the acceleration in meters per second squared of a radio-controlled drone moving in a straight line during a particular time interval can be modeled by this function. So this is acceleration. So as I always say in your test, really you should be labeling these things, acceleration. Where t is in time in seconds, so all of our t's are in seconds after the drone begins to move. If the speed of the drone is, now, if we're going from acceleration back to speed, what we're actually doing is we're integrating. So we're going to have to integrate the acceleration in order to get our speed. And of course, it's dt because we're doing it in terms of t as opposed to x. So how do I integrate this? Well, I have my 0.2 t. Now that's going to be squared divided by 2. So this is just my regular integration. Maybe before we begin, actually, it might be a good idea to just write that as power of a half. So what happens is I'm going to end up with 2, 0.3 t to the 3 over 2 all over 3. Now, the reason I get that is because I'm dividing underneath by 3 over 2. And if you remember from class, dividing by 3 over 2 is the same thing as multiplying by 2 over 3. That's why the 2 has ended up there and the 3 has ended up down here. And of course, we increase the power by 1. Now, we have a plus c, our constant of integration. So we'll just tidy this up first, 0.1 t squared. This is going to be 2 times 0.3, so that's 0.6 divided by 3 is 0.2. So that becomes 0.2 t to the power of 3 over 2 plus c. Now, it does say, if the speed is 1.4 after 1 second. So what we're going to do is anywhere there's a t, we're going to put a 1. So anywhere there's a t, we're going to put a 1. And we're going to let it equal to 1.4 because we're told that that's what the speed is at that stage. So we get 0.1, 1 squared is 1. And again, 1 to the power of 3 over 2 is going to be 1. So anything, 1 to the power of anything is going to be 1. Now we're going to bring it all to the one side and we end up with 1.1. So now that we know what the constant of integration is, we can write our 0.1 t squared plus 0.2 t to the power of 3 over 2 plus 1.1. So we're just replacing the c with what we now know to be the constant of integration. You were then asked to find the speed after 5 seconds. So now we're going to put 5 in the place of t. So anywhere there is a t, we're putting a 5 and we end up with 5.8 meters per second. And that's that one done.